My name is Sebastian Elmgren. I'm head of business development for dedicated networks at Ericsson, and I'm located in Stockholm, Sweden. So I will talk a bit about the industry challenges, show you some of the use cases, talk about 5G technologies that are used for the smart factory, and then end up with some slides on our own factory, the Ericsson Smart Factory, as a best practice, as well as some of the customer engagements we have. But let's start with some of the industry challenges. So a manufacturer today is facing a lot of different challenges in their daily operations. One of the largest ones is the customization. As you see here, there's more and more customization that is required by customers, requiring a more and more flexible production. And that leads to requirements on wireless connectivity. But there are also issues like stagnated productivity. We don't see the productivity growing as before. There is a local production footprint. We need a more flexible supply chain, meeting the demands of the future. There is also shortages of competence. There's a lot of manufacturing jobs that lacks skilled applicants. We see a lot of brownfield deployments. We don't build a new factory so often. We need to work with what we have. And then, of course, to round this up, the data security. There's sensitive data being handled, so everything we do within the connected factory needs to be very, very secure. And asking manufacturing companies, 86% of them do believe that smart factory initiatives will be necessary to remain competitive. So we will see an interaction between humans and machine work hours. So you can see some of the examples here, everything from decision making to information processing, where there will be a split between machine and humans. And there will also be a potential here. So the companies who can embrace this technology and push the technology furthest will have a competitive advantage. And we see in some of this area, there's a huge potential for adding more automation. So what are the use cases for the smart factory? So if you look at the typical smart factory, connectivity comes in stages. That's supposed to do with the maturity of the enterprise as well as we see the development of the technology. So the first phase, where most companies are today, is for connectivity monitoring and tracking. We see use cases like enhanced video services, monitoring and tracking, hazard and maintenance, monitoring. So it's non-critical applications, not extreme amount of data, but still creates a lot of value for the enterprises as it solves some of the fundamental challenges. The next step we see some companies have moved into is the advanced analytics use cases, where we see business critical applications being deployed, like remote operations, real-time automation, augmented reality solutions. So this puts a high demand on reliability on the networks, and is also starting to push much more data through these networks. And then we have the third step, which will be seen coming under the next year for the most advanced enterprises, and that's the adaptive operations. And here we see mission critical applications like autonomous robots, VR planning and designs, digital twins, smart surveillance, all with extreme requirements on reliability, and we're talking terabytes per hour in data being pushed through the systems. So this is what enterprises are adopting, and also what the networks are evolving into handling. And one of the main advantages, as you will see during this presentation with 5G, is that it can cover a large amount of use cases using the same infrastructure. So it's a very flexible technology. So here are some of the key use cases that we see today. So we have the monitoring, tracking, real-time automation, smart surveillance, remote operations, enhanced video services, hazard and maintenance sensing, augmented reality, connected vehicles, and so on. And as you see, the requirements of this application are quite different. So we have everything from simple sensors, long battery lifetime. We have bandwidth requiring solutions for the video services. We have mobility requiring solutions like augmented reality. And we have solutions that require low latency like real-time automation and remote operations. And all of this can be handled by the same network. It simplifies a lot and lowers the TCO for the enterprises. So what technologies are making this possible? So as you see here, 5G is a huge innovation platform for any kind of full connected smart factory. And again, the technologies that we are enabling with the 5G network covers everything from multiband next generation radio with extreme capacity for those applications that requires that. We have slicing to divide the network into different sub-networks for different requirements. The time-critical communication, which makes it possible for deterministic networks with low latency requirements. And we also have RedCap and narrowband IoT, which reduces cost and also prolongs battery lifetime for those devices that requires that, like simpler sensors and so on. So we have all of these technologies in the platform, creating a flexible fundament for building all kind of different applications on top of. So this is really a platform for innovation. And as you saw, the multiband coverage, that's what's really providing the extreme capacity. And that's the capability to build capacity using different frequencies. So we can take the low band, mid band, and the high band, adding on top of each other, adding more and more capacity where it's needed. And in combination with flexible TDD patterns for the millimeter wave, we can meet the high capacity with a very low latency and also be flexible when it comes to where we want the capacity, if it's uplink or downlink. And especially in the manufacturing scenarios, we see a high requirement on uplink compared to the normal mobile broadband networks, where it's more downlink heavy applications. And the slicing, that's what makes it possible to deliver all these different kind of services to the different kinds of terminals, whatever they need. So to have this one flexible network instead of having a multitude of networks, as you could see in manufacturing today, with a Sigma network, a Bluetooth network, a cable network, and so on. You can solve all of those applications with one single network and use the slicing to make sure that every device gets exactly that SLA that is required for that application. If you look at the time critical use cases here, we can see that there is differences between those as well. So we have some of the time critical as quite loose requirements on latency and reliability, around 10 milliseconds and 99% reliability, like process monitoring or cloud-based, cloud-assisted basic AR. And then we can push the technology all the way up to the really required, demanding use cases, down to 1 millisecond of latency and 999 reliability. So that's when we look at motion control, cloud motion control of AGVs, and so on. So when you talk about time critical use cases, even there is a broad array of different requirements on the use cases, and also different kinds of application, everything from industrial control, we have mobility, automation, remote control, and if you look at the media concept, we have the real-time media production, and all of them need these kind of networks. And this is the way Ericsson approaches the TCC. So we make sure we have a service separation. We are addressing causes for latency throughout the whole chain, and we maximize the performance throughout the whole chain. So really taking a full end-to-end concept here for the application to be able to provide the TCC. So here we have one examples where we have worked with time-sensitive networks enabled for PLC. So this is the PLC is the control box that handles the logic in any manufacturing environment, and we have worked together here and created a PLC that uses the time-sensitive networking capabilities of a 5G network to do the real-time automation in the factory. And this has huge potential, as you see in this graph from HMS. Right now, cellular technology is hardly on the map for the industrial protocols that are being used today. And many of these are old protocols that could be substituted with a new wireless reliable technology as 5G grows into these areas. And here we see an example of the industrial PLC collaboration we have done with CMCC. So this is the world's first PLC integration on a low latency millimeter wave band, where we have a UE connected to a robot over millimeter wave into the baseband and all the way up to a cloud-based PLC, really removing the cables in a factory and enable very flexible production, where you don't need to have this distributed control boxes all over the factory, but you can have one central brain and use a reliable low latency 5G network to handle communication. But everything is not about low latency and high bandwidth. We also need the simpler devices. So that's where 5G and our RedCap comes in. So that will build on the consumer smartwatches chipsets, but get an industrial application. So we will see industrial AR and wearables for these chipsets with reduced capability and longer battery lifetime, but the performance will still be higher than what we see on LTM and narrowband IoT, but at a much better price point and longer battery lifetime. And we will see sensors and video surveillance as well coming in here. So there will be a lot of exciting applications coming with RedCap standard being introduced, and building on the volumes from the consumer side, we can see a very attractive price points on these kind of solutions as well. But all of this needs to come together in a digital twin in order to become a fully digital and optimized production. So this is where all the different applications and sensors comes together in a digital twin, making it possible to work and optimize your production. And that's what we're doing around the world now, deploying these use cases, putting them all together into the smart factories. You can see some of the engagements here. And one of the flagships that we have is, of course, our own Ericsson US factory, which we built from scratch, introducing all of the latest technologies. You can see some of the use cases here. It's mainly the things I've talked about before, and then put all together into a digital thread or a digital twin of the production. We also make sure we do this in a sustainable way, with both when it comes to energy and water handling. Everything is to the highest standard of sustainability. And of course, what do we do there is the 5G radios. So we produce 5G radios with 5G technology. But we are not the only customer of this. We have a lot of success stories here. So here are some of the most recent examples. We have worked with Airbus for their manufacturing in Europe. And we are also deployed networks together with Nestlé in Brazil for automating parts of their production. So thank you very much for listening to me. Hope you got a good snapshot of what we've been doing within this area.